I'm going to discuss how to build a peephole optimizer using Ohm-JS. The idea is to optimize code in the simplest way possible. If you haven't already seen the overview of what I'm building, you probably should go to this YouTube and watch it. So this optimizer changes JavaScript to more JavaScript. It just gets a little bit more detailed as we go along. For example, we match a function call like cache at .@num and turn it into an array reference in JavaScript called that is cache square brackets num. The peephole optimizer itself has a very small grammar, and I use the Ohm-JS features of lexical rules, syntactic rules, and apply syntactic. If I take all of those together, I get a very small program. This technique of peephole optimizing was originally discussed in a Fraser-Davidson paper. It was used in GCC. Fraser-Davidson called it RTL, Register Transfer Logic. And then Jim Cordy's thesis, PhD thesis on orthogonal code generators, further generalized the technique beyond what Fraser-Davidson did. And here are some references that you can look at for that. So the optimizer grammar is quite small. It fits on less than one slide. It basically says that we use an Ohm-JS lexical rule, which starts with a lowercase letter, and we say we see one or more peepholes. And a peephole consists of anything, but if we see something that looks like a function call first, then we'll apply that first. And a function call looks like a dot followed by an @ followed by a parenthesized set of arguments. And then down here I say what arguments look like, and using peg I can go to nested arguments. So if the arguments list contains parentheses, the argument list itself is parenthesized, and if it contains further parentheses, peg and therefore Ohm-JS can handle it by recurring. And if there's anything other than parentheses, we don't care. We just take whatever character there is and keep going. The reformatter, I've written a small preprocessor language that helps me create Ohm-JS semantics code, which needs to be JavaScript, but I didn't feel like writing that much JavaScript. It was all boilerplate, so I wrote this instead. And so this basically says each one of these rules has to match a rule in the grammar. If we go back to here, here's the grammar. We get top, peephole, at function call, and arg. Each one of those grammar rules can, when they're walked, they call these JavaScript rules. These JavaScript rules say, let's go down to here where there's, say, if we get a peephole, then the grammar parser tree walker will take the match and assign it to the variable x, and then here I will simply put in the variable x. In almost JavaScript template syntax, this squiggly turns into a $sign at the end. And these strange brackets are actually ASCII brackets, but Obsidian is fooling with this stuff, and I have to write it this way to get it past Obsidian. If we get a function call, if we see something that looks like pattern matches a function call, then we're going to get a bunch of parameters. One is the dot, one is the at, one is the left parenthesis, then we're going to get a bunch of args, and then we're going to get a right parenthesis. This at sign corresponds to this this star. So star, plus, or question mark have to be prefixed by at signs in this rewrite grammar. At the moment, the rewrite grammar transpiler doesn't check to see that there's a proper correspondence. Somebody could write a piece of code that said, why don't we look at the grammar and see that this really is a plus or a star or a question mark thing, and then we could keep going, and we could write another grammar that said, why don't we just take this, convert this transpile this from the original grammar. Whoops. There we go, from the grammar here. So if we saw this, we should transpile it to this. Or transpile it to this, actually. And then this part here says how I want to rewrite it. And it turns out that in this case, I want to dump, forget this, forget that, forget that, forget that. All I want is access to this, to the tree walk of this iterator node called args. And then I want to paste it into the final code, and I will want to put square brackets around it. And and then if we have arg nested, then we get 3 matches, 1, 2, 3, and this one is a tree of matches, and the preprocessor, the glue language, will turn this tree into a string, and then we'll take these strings and slap them together in this order. So we take the left parenthesis, all of the args that came out of this tree walk here, and then we'll put the right parenthesis in. And if we see anything else, then we just don't care what it is. It'll be a single character, and we'll just take that single character and pass it back upwards recursively. The format tool is currently evolving. I previously called it glue, and then before that I called it grassum for grammar and semantics. That's what I meant by that. The latest documentation that I've got so far is in the prep tool documentation, if you see the glue format section. An earlier documentation, which is a slideshow, can be seen here in the glue tool. In appendix, here's the GitHub code. Here's where you can find it, including all the references.